Let's start this demo by taking a look at a synchronous example, and then we're going to spin this into the asynchronous example. So for our example in both cases, what we're going to do is we're going to make a call out to a little web service that does kind of very simple things for us. In this case, what it's going to do is it's going to delay. It's basically a REST API version of a sleep call. I personally don't like doing demos with that really depend on sleep calls. You are going to notice I'll do a little bit of that in the other one, but I generally try to avoid that just because I don't think that they're necessarily real world, that whenever I look at that I'm like, oh, well, you want to improve performance? Just take out the sleep call. Problem solved. Maybe that's just me. But yeah, so instead I always like to call out to some other service, and this is just sort of a simple way that we can do this. So more than anything else, it's a fancy sleep call just because of the fact that we're calling an endpoint. You're going to notice to start with that we're pulling in the time-it library. I'm a huge fan of the time-it library just because it gives us the ability real quick and easy to see how long something takes. So we're just going to set up our default timer and we'll stop and start a stopwatch effectively and then print out however long this took. We're going to bring in the request library, which we talked about in our prior Python videos. And this is by far the most common library for making HTTPS calls. The thing about the request library, though, is the fact that it is synchronous, meaning that it's always going to stop execution. If we want to do this asynchronously, we are going to need to do something different, maybe use a different library. And that's actually what I'm going to do in my other demo, is use a different library, a library that's built for asynchronous programming. Now, inside of here, I'm just going to ignore the little prints and things like that, just because all that that's doing is just making the demo look a little prettier. So we're just saying, hey, we're starting this, stopping this, starting this, stopping this. So I'm not going to focus on the prints, but instead, I want to focus in on line 6 here, which is where we're now going to make our get call, and we're going to go get the text here. Now, you're going to notice that we've got one parameter that's called delay. Delay is going to be X number of seconds that we want to delay. And you'll notice that when we run the demo here, that in our demo, we're going to go ahead and make a 2-second delay call, and then a 3-second delay call, and then eventually print out however long it took. OK. Now, all of that's wrapped up inside of a neat little run demo. It's wrapped up inside of main for reasons we'll talk about in the next section. And now we're just simply calling main. So now let's go ahead and bring this together by saying Python and then my little sync demo.py. And what you're going to notice is that this is performing the operation synchronously. So it started the 2-second delay and then finished. It started the 3-second delay and then finished. And you'll notice that the entire operation took 6.3 seconds. Again, that extra 1.3 is just because of how long it took to spin up and tear down the appropriate connections. That's not necessarily a great way to program that. If I'm working with something that's single user, maybe I'm putting this inside of a Jupyter notebook. By the way, there might be another course where we talk about Jupyter notebooks. Go check it out. But if I'm putting this inside of a Jupyter notebook, it's just me. I'm not necessarily doing anything else. I can't move without waiting for the value here. Then just go ahead and do this. But if I am building something up that's going to be multi-user, or I want it to be better performant, then I'm going to need a better answer. So this is that next section that I'm talking about. This is now where we're going to get in and start to work asynchronously. So what I want to highlight up at the very top here is we're pulling in 2 little libraries here. We're pulling in, first of all, AIO HTTP. Now, the big thing that I want to highlight about this is the fact that this is another library here. So it's not the request library. This is not built in with Python, but rather it's a different library. AIO HTTP is all about async IO and making HTTP calls. Now, the way that this does its magic is it's all based around a session object. And typically what you'll do is you'll create one session and keep reusing that over and over and over again. And this actually gives you a little bit of additional performance because of the fact that it's able to reuse that connection if possible. So it does a little bit of connection pooling for us automatically. And in fact, we can see right here that we're going to create that session one time. Now you are going to notice that if we're going to use a wait inside of a with, that we do need to mark that as async. Now, why is async important here? Well, the reason that async is important is because it's basically telling our runtime, hey, there's going to be an await command in here. And the key to an await command working is that my runtime needs to understand what that is. My runtime needs to understand, hey, we need to pause here. That's why we have that async. Now, having that on a method might make sense because after all, we're going to call await eventually on that method, so maybe it makes sense there. And then on top of that, when the method ends, I mean, it just simply ends at that point. So we want to make sure that the runtime knows that somewhere in here, there's potentially going to be a blocker, there's going to be an await. With behaves the exact same way, that if you remember back to the prior module, we saw with, and the whole thing about with is that it's going to do automatic cleanup for us. Well, we don't want it to clean things up before we're done using them. And so again, when we're going to have that await, we're going to pause right here, wait for something else to complete somewhere else. As a result, we need to make sure that the outside is aware of that fact. That's what async is doing, is it's letting everything know, hey, inside of here, we're going to have a pause for something else. Don't leave without me. That's basically it here. So that's why we have that both on the with statement here and on the little function. What you're also going to notice right here is we're going to do the exact same thing with that load data, put in a 2 and a 3 second delay, but this time we're going to pass in the session. And then if we spin it on up to the top, what I want you to notice is sort of a similar syntax here, where now we're going to go ahead and call that session get, and then we're going to go ahead and grab the text from that. Now you're going to notice that I've got my await right here, because calling out to get the text, that's going to be an asynchronous operation. So that's what's going on here. That's the setup for that AIO HTTP. So it's a little bit more work than we had for our requests because of the fact that it's asynchronous. Now, what makes the asynchronous magic happen in Python is this async IO. Now, async IO is new to Python 3.4, and it's had a lot of changes since then. There's constant churn here. So I do want to highlight the fact that we're recording this at a point in time. So the code that's here will only run on Python 3.7 or higher, just this example here. So if you're running this on a prior version, you can do this. It's just a different way to go about this. I really like this implementation. This feels much more natural, especially as somebody who's worked with async await in other environments. So this is only going to work on Python 3.7 or higher. So you're going to notice that we pull in this async IO library. Now, what you're going to notice with async IO is we're now going to create these tasks. This is basically that process, or that promise rather. This is where I'm going to say, hey, load data, go do something. Go do this. And then when you're done, make sure, promise me that you'll let me know that you're done. Promise me that you'll go get that value and you'll give it back to me when I ask for it. That's what's happening here. So we're setting that up. And then what we're going to do is we're going to say, all right, now we're ready for that value. So now I'm going to say, hey, give me the value back from the 2 task. Hey, now give me that value back from the 3 task. Now, I'm not printing them out in this case, mostly just because it generates a lot of noise on the screen, because what the text gives me back is the full JSON response from the endpoint, and it just gives me a lot of extraneous data. So I'm just trying to keep things relatively streamlined here, so I'm not going to worry about printing that out. I'm just simulating grabbing the values here. That's really the important part, is that ability to go ahead and grab the value. Now, what's great about setting up those tasks is the fact that I can do other work here. So that other work might take a little bit of time. So this is now where I'm going to do that sleep. So now I'm going to sleep for a second, and then I'm going to print out doing other work. And then finally, at the very end, we'll print out whatever the timer was. And when I run this code, what you're going to notice, let me just clear my screen here, is it starts both timers, it does the other work, it finishes both timers, and then the total elapsed time that it took was 3.3 seconds. Again, that 0.3 is the buildup and teardown of the HTTP calls. But now what I want you to notice is the fact that we actually had 3 quote-unquote long-running operations. We had the 1-second sleep timer, and then the 2 and the 3-second delay that we were calling out to that HTTP service. And in the end, it only took 3.3 seconds. This is what async await is all about. It gives us this ability. It gives us the ability to, without necessarily having to spin out different threads and manage them and so forth, be able to still take advantage of a little bit of potentially multi-core, or just the ability for Python now to be able to swap things on and off, because now we've given it a little bit of a heads up of the fact that certain operations are going to be long running, and it's okay if it does something else. That is async await inside of Python. Now, I again want to stress the fact that there's a lot that's going on here with async await, and we are going to link to more information inside of the GitHub page. So if you want to keep digging into async await, you can absolutely do this. And I will say that in today's day and age, understanding async await is one of those core concepts that you will want to become familiar with. I also want to highlight this fact. Async await, or rather async IO in Python, is still actively being developed. Things are going to change over time. So the code that's here, while it will likely continue to work in Python 3.7 and higher, there's a very good chance how things change, or how things work, may change. And there's also a very good chance that there might be cool new fancy ways to do things as well in the future. So again, we're recording this at a point in time. Right now, this is the way that, that things behave. Things could always change in the future. So all of that is how we can do async await in Python.